So what exactly does that mean? Just understand. So when we are doing a chemical reaction, that means, when let's suppose I mix H2 and I mix O2 and I heat it, so I get water. That means H2 by nature is hydrogen gas. Yes or no? And oxygen by nature, what is O2? O2 is by nature oxygen gas. And H2O is by nature water. Yes or no? H2O by nature is water. I hope you're understanding. So you understand that, when we are talking about H2 and O2 and oxygen gas and water, I hope you're understanding that, what is a chemical reaction where two chemical substances combine, where two chemical substances combine to form a new chemical substance, to form a new chemical substance, right? So such a reaction, this is called as a chemical reaction. That means, see, understand, I'll tell you. H2. You know what is the nature of H2? H2 gas, hydrogen gas is a gas which catches fire very quickly. You understand? Which catches fire very quickly. And what about the O2 gas? What about the O2 gas? O2 gas basically helps in the burning of something, helps in the combustion. You know what combustion is? Helps in the burning. You understand? So when we are talking about the burning of the O2 gas, it basically means the burning, the combustion part. Yes or no? And what does water do? Tell me. If there is a flame somewhere, water, if you put onto that flame, the water extinguishes that flame. The water extinguishes that flame. Are you understanding? That means what? That means what? It means that, H2 and O2 have two different chemical properties, and water has totally new set of properties. Even though H2O water is being made from hydrogen and oxygen, it does not behave at all like hydrogen and oxygen. It has totally new set of chemical properties. Are you understand? So this is a chemical reaction. This is a chemical reaction. So in a chemical reaction, you generally do what? You perform that chemical reaction in the laboratory. You understand? You perform that reaction in the laboratory. So it's not something that, you can write down anything on the screen or on the paper and that's it. No. You have to go to the laboratory to perform that particular reaction. Do you understand my point? So now what is a chemical equation? What is a chemical equation? You understand? When we are talking about a chemical equation, actually a chemical equation is a symbolic representation. A symbolic representation. So chemical equation is a symbolic representation of a chemical reaction, of a feasible chemical reaction. To be more precise, of a feasible chemical reaction. What is a feasible chemical reaction? What is a feasible chemical reaction? A feasible chemical reaction is one, you know, which basically, which is possible. See, it's like if I say that, CO with water and I say CH3OH. Now I have written down this equation on the page. But in reality, this equation will not even, this reaction will not even take place. This reaction will not even take place in the laboratory. So do you understand that there is no point of, writing down this equation? Because when you really go to the lab and you try to perform this reaction, you take a beaker and you add carbon monoxide gas and you add water and you heat it. So nothing is formed. No reaction takes place at all. So does this chemical equation has any meaning? No, this chemical equation is meaningless because it is actually not representing any reaction. That means by the equation, when I see that, CO and H2O is there. So when I have CO and when I have H2O, I hope you're understanding that CO and H2O, according to the equation, tells me that go into the lab, take a beaker, mix carbon dioxide and water, and then heat, and then you should get this. That's what this equation is telling me. And this equation, as an instruction, when I perform, I get nothing in the lab. That means this reaction in reality is not even happening, which means that, chemical equation, I can write down a chemical equation to express myself on the page that how a particular reaction happened in the laboratory. Are you understanding? So when I say H2 plus O2 gives me H2O, I hope you're understanding that, in laboratory, if I mix hydrogen and oxygen and I heat it, I must get water and I will get water. So, first of all, chemical reaction. So, I see, understand, if I write down hydrogen, full name, hydrogen gas plus oxygen gas gives me water. You understand? If I get this. So, this is how if I write the equation. So, my equation will always have this arrow. The amount or the reactant or the chemical substance which is formed. A new chemical substance, a new chemical substance, which is formed is called as a product. The new chemical substance which is formed is called as a product. You understand? And H2 and O2 are my reactants. They are combining. So they are reactants. Reactant means which is combining. Are you understanding? So on the left hand side, I'm writing down the reactants, and on the right hand side, I'm writing down the products. Are you understanding? So this is a feasible means possible. Feasible chemical reaction. This is a feasible chemical reaction. Are you understanding? And if it is a feasible chemical reaction, that means what? That means what? You tell me. That I can put down that reaction into the form of an equation. So equation is a shorthand form. Equation is a shorthand form in which I am going to represent what? That H2 is a gas. So how would I tell you the state, the nature of the H2? I would put a small g. Small g stands for gas. O2 is a gas, so I will put a small g in front of it just to tell me the nature of H2. The reactant H2's nature is gaseous. O2's nature is gaseous. And H2O's nature is liquid, so I'm going to put a L right here. Right? So the nature of H2O would be liquid. Understood or not? You understand? So H2 gas, O2 gas, H2O is a liquid. And this delta symbol, this triangle that I'm marking right here, this triangle would be a, represents heat. So if I have to write down in the full formation, I would write down heat. But to put it down into symbolic form, the symbol for heat would be the delta triangle. Triangle means you are taking a burner and you're burning it with the flame. Are you understanding my point? Do you understand? So this is how a chemical reaction has to be represented in the form of a chemical equation. Now, sometimes, when we go to the lab and, we are doing a particular reaction, we take a beaker, and we in that particular beaker, what are we doing? In that particular beaker, we are sort of, mixing two new substances, hoping that new substance shall be formed. So, what is going to happen? Just understand. What is going to happen? What makes me, justify that, now the chemical reaction has taken place? What makes me justify that? So I will say that, I can see a change in the color. Like, for example, the reaction was happening. And if I do FeSO4 dot 7H2O, this is one of my reactants, right? So if I heat it, I get it was green in color. It is green in color. And after heating, it becomes simple FeSO4 and 7H2O gets lost. and it becomes white in color. So when something is coming out of the beaker, so water is coming out of the beaker, so I'm going to put an arrow sign upwards. What do you mean by the arrow sign upwards? Tell me. The arrow sign upwards means that, whatever H2O was there in the beaker. So we had this green colored FeSO4.7H2, and after heating it, the H2O leaves the beaker in the form of vapor. So we put an upward arrow. This upward arrow indicates what? This upward arrow indicates what? You tell me. Leaving the beaker. Exactly. Not the reactants. One of the products is leaving the beaker. One of the products is leaving the beaker. You understand? So this is what my equation tells me. So how do I understand that, the equation the reaction has been performed? How do I understand that? How do I confirm that? That the color is changing, right? And if something is coming out, what can I do? I can take this beaker and, I am performing the reaction here. I can close the beaker and I can put a pipe, and I can put that pipe into a second beaker, and that second beaker has lots of vapor, some liquid dissolved into it, right? Some liquid is there in this beaker. So because of that, the bubbles shall be formed. And the bubbling represents what? The bubbling represents, there is some escape of the gas. Because obviously when a gas is being, produced in some liquid, the bubbles are formed. I hope you're understanding. So escape of a gas indicates that some reaction is taking place. Some reaction is taking place. Color change, if I get to see, right? Some temperature change. Sometimes this happens that, you're performing the reaction in this beaker and the beaker gets heated up. When you touch the beaker is actually heated up. So that means some heat is being produced, or the beaker becomes very cold. Heat is being produced, or the beaker becomes very cold, or the beaker becomes very cold. That means what? That means what? That, these are the signs that a reaction has taken place. Sign of a reaction taking place. You understand? RXN is a shortcut for reaction. Understood? So that's how the reaction is being placed. So color change, I can see some heat being produced, some bubbling being produced, right? Bubbling means some escape, the gas is being escaping out. Or what extra you can see? The formation of a precipitate. The formation of a precipitate, right? The formation of a precipitate. What do you mean by the formation of a precipitate? Like for example, you take a beaker, and when you mix the two reactants, you mix the black reactant with the blue reactant. And after a period of time, what do you see? You see that in that particular beaker, a green liquid is formed, you know, and a red solid, and a red solid is being deposited at the center, at the bottom. So the green liquid remains at the top, isn't it? And the red solid that is there, that is deposited like a mud gets deposited in the water. That means this red deposited substance, which is insoluble in the liquid, which is insoluble in the liquid, is called as a precipitate. Is called as a precipitate. Yes or no? That means what? That means what? That, ma'am, when you're mixing the reactants and you're expecting the products to be formed, I hope you're understanding that, sometimes one product might not be soluble into the other. Like in this example, two new substances actually got formed. When the blue reactant combined with the black reactant, a green and a red compound formed. New compounds formed with new properties. But the red and the green compounds were not soluble into each other, and one was heavy. Because it was heavy, it will settle down at the bottom. Yes or no? Because it was heavy, it will settle down at the bottom. And the heavy component which settles at the bottom is called as the precipitate. Are you understanding? So that's the thing. So if I write down an equation like this, if I say AgNO3 plus NaCl, and I will get AgCl and NaNO3. So AgCl shall be precipitating down. So I put a downward arrow. So downward arrow means what? Downward arrow, if I'm representing on the equation, that means what? Downward arrow indicates the formation of a precipitate. You understand the formation of a precipitate. Understood or not? Right? So that is the concept. That is the concept. So first thing first is that a chemical equation is a shorthand notation for a chemical reaction. A chemical reaction, when you perform in the laboratory, you notice down all the changes and then you put that chemical reaction on the paper in the form of a chemical equation. In the chemical equation, you do not write down their full names. You write down how? You write down their symbols. Their symbols. H2O2, H2O. And in the symbols, when you're writing down, you write an arrow also. That arrow indicates that you know what is the reactant. The left hand side would be the reactants and the right hand side would be the products. And indicating the arrow indicates from where to where the reaction is actually moving. You understand my point? Hmm? That's how the reaction is going to be. That's how it is going to be. I hope the concept is clear. Yes or no? Okay. And how do I get to know in a laboratory that the reaction is being done? Either I can see the change in the color, either I can see the change in the color, or I can see a foul smell, or some fumes coming out of the beaker, or I can see a bubbling of the gas into another beaker. Then I can see either the precipitate formation, right? All of these changes, if I see in the laboratory, I am confirmed that a reaction has actually taken place, in which old new substances, when they combine, they form a new product. And when they form a new product, that new product shall have completely new set of properties. You understand? That shall have completely new set of properties. Understood or not? So products have completely new set of properties. That's the basic start of this chapter, whereby you have to understand. And writing down the equations is a definite part. But first is what is a chemical reaction and chemical equation. Chemical equation you are representing on the paper. Chemical reaction you are performing in the lab. And a chemical reaction, if you know, is can be performed, only then you write down the equation for that. Understood or not? Right?